Okay, just a few announcements. I left the hard copy of your syllabus on the two spot over there and over there. When you leave the room, you can pick up one copy. I should have enough for everybody. The second thing is that regarding the TA situation, let me turn on. Hello. Okay, better. Regarding the TA situation, I just got an email yesterday that one of the TA quit as to be our TA. So today, fortunately, I managed to recruit another TA. So just let you know, the TA situation is being stabilized, and then you will get more information about discussion and other things. The third thing I want to announce, which I will actually talk about today, is about homework assignment number 1. So homework assignment number 1 has been released. And I'm going to talk about homework assignment number 1. And there are some exceptions I would like to get you notified when you work on homework assignment number 1. And number 4 is that I create a GitHub folder for this class. As I realized, during this this quarter in different lecture, I will need to use some file. So by the way, it's a programming. It's important for you to actually not just see the PowerPoint slide. You can get a code. I actually don't like to use PowerPoint. To a point, I really like to use the compiler interpreter environment so I can actually show you how this thing really works. So it will be really good for you to actually be able to download those files, even within the lecture, that you can actually play around a little bit. Definitely, after the class, you want to actually repeat what we have went over in lecture, and you can actually really see what's going on. So all the file that's actually being used during the lecture, during the discussion, during anything that's actually for this class, I'm going to deposit into that GitHub. By the way, it's really inconvenient. I'm still need some intelligent advice about how to deal with that, because right now, before I have the TA, everything I have to do is 3 times. If I want to make an announcement, I have to go 3 places. If I upload a file, PowerPoint file, for example, I have to upload all 3 places. And I want to share video, homework assignment, all 3 places. I definitely want to reduce that workload. So just one single place, just make sure that I won't forget one of the sessions. Just let you know. So from now on, if I have a file, I will try to push into the GitHub, and you can actually go there and grab it. Okay. All right. Any question before I start today's lecture? Okay. First thing, I want to turn off the light a little bit. Anybody know this advanced room? How do I turn off the light? Thank you. See, all the students can see exactly. You guys, okay, right? You really need the light, let me know, okay? Okay, I think I'm in recording, so I directly go to, let me hold on. I actually got something wrong here. Wait a minute, why my PowerPoint didn't come up? Okay, now I have this. All right, that's good. So I'm actually going to use this as an example. So this picture, I hope you will remember, because it actually just not representing a box of objects that's related to baseball, but it has a lot of message related to how we view object-oriented technology. But by the way, there is one important thing I want to emphasize. You can think about this, is that when we learned about programming language as student, because I was a student, I actually a CS major in 1981 to 1985. I was the first generation of undergraduate computer science major in my university. And the thing is that at that time, I have a tendency to try to learn the language fully. I try to understand every single feature that this language can provide to me. And so I can master this language. I mean, the attitude is not wrong, but in the modern technology advancement, this might not be the best way to learn programming language. In fact, I want to use this differently. I want to tell you that every single programming language construct, including object-oriented, it was developed because somebody actually saw the need to have this feature. So essentially, instead of trying to understand the language, you try to start to imagine what's actually needed in the application domain that you try to create or you try to solve a problem. And then you try to see whether, based on that need, you try to search for exactly the feature that's actually being created or being used before in this programming language. And in a lot of programming language, it has been created for a long time. I mean, C++ was developed probably in the late 70s, before it was even published, and has been used in so many different application scenarios. And then people has developed so many different things. And therefore, it must be already there. If it's not there, then the language, either you choose the wrong language, choose the wrong tool, or the language has something which is really allow you to actually customize or extend what they provide and to learn. So in other words, what I want you to think about, the reason I actually show you this is that this is, of course, it's not C++ or any programming language, but it represents a need for us to representing information. In fact, if you think about what is a computer programming language, you can say, oh, solve problems, whatever, but it reduces to how do you represent information and how do you process that information. It's really this two. How do you represent the information and how do you process that information? And the thing is, you can think about that. How do you actually answer that question? There is no universal method or universal representation. Instead, it's always triggered by your need. If you're an engineering major, you're solving electrical engineering or mechanical engineering, you have the need to represent the physical world you're dealing with, or the electronics you're dealing with. If you're from social science, cognitive science, and you have a need to represent somebody's mental status, and you have the need to understand how do you represent the mind will work. So this is really, really triggered by your need. And therefore, this quarter, what we try to do is that we're going to teach you a few way or a few general methodology that you can actually dig out what is the construct in the language that will fit your need. And in some cases, what you exactly need is not there, then you use some of the tool, like inheritance, for example, to actually pull it out, to work, to do the exactly things you want. Okay, so let me just show you another example. So one of the things I mentioned this is called object-oriented thinking, which means that you want to find a way to advance our society. And by the way, one of the things I mentioned yesterday, not yesterday, Wednesday, was that, okay, it's some objects that's actually in my garage, but that object is not just necessarily a physical object, but that sometimes object could be abstract. For example, that abstract could be a person's interaction. And one of the examples you probably already use it all the time is called social media. And in the social media, you have somebody share a content and people can click like. People can actually show their emotion, response to your post. And the thing is that is actually a object. If you look at this page, this was by the way a page that created for a long time ago for ECF30, but I pretty much use Facebook all the time. And then when we actually dig into how they represent, this is actually their object representation. This is called JSON, JavaScript Object Notation. You can see that everything you want to represent as a social media, which is social media, to me, is a really simple preliminary format about how humans should interact in cyber world. We should be able to do a lot more advanced than that. But the fundamental principle is that we already engineered. This particular one is actually 2012. I try to remember what this was. This must be one of the problem solving that we try to deal with. And then we actually ask the student to post on Facebook and then look at their object-oriented representation. So they will be able to see how the information can be digitized, and then they know how to handle that information, okay? All right, so I'm actually going to, that is kind of all the motivation. So now I'm going to start to look at this 4 core chapter. This quarter, I would like to cover. Those are the most important things you need to learn this quarter about how you handle the concept of object orientation. Okay, so the fourth thing is chapter 11, deal with data abstraction. Chapter 12, your textbook dealing with polymorphism. And chapter 13 is inheritance. Chapter 14 is encapsulation. So I'm going to start with the first chapter, chapter 11, data abstraction. So the basic construct about object-oriented is a concept called object, and also sometimes we call class. So what you will gradually see the difference between what I mean object and class. I mean, the way I will say is that if I have a product, then the spec of the product is class. But the real product is object. So every object you create should follow the spec as the class. All right, so that's the difference between the object and the class. And so I'm going to first actually tell you what are the most important elements in a class, because that's the spec. And use that class, I can actually create some object. So the first one is data, because remember I said information. Now, how do you actually represent the information related to this class? For example, if this class is a class called person, that's the spec of a person, what a person should have. For example, a person should have a name, a person should have some sort of social security number, if we talk about US, and the person should have things like a birthday, information, attribute. So those things are the data that's actually being kept as a class. So the first thing is called data or attribute. The second way is called method. So method is about processing of those data. So the thing is that what we want to do is you have a bunch of data, but object-oriented, this part is really motivated by software development, is that I want to make sure that whoever decide to use this objects or this class, they will not misuse. They will not misunderstanding what's the data format, how to handle this data. Therefore, they kind of create a bunch of method, or sometimes we call interface, to allow people to actually use this data. Okay, so those are the two most important elements within an object. So let me actually just show you graphically how it looks like. I mean, usually the way I draw it, it looks like this. So this is an object, it's a circle. And within the object, I have a bunch of data. I mean, I'll show you real code example in a moment, but right now, let's just look at the picture. So I have a bunch of data that's actually put it inside this object. And then I have a bunch of interface or method that's actually provide to other program when they try to use this object, they're going to call one of this method. And you can imagine each of this is just a function, a piece of code. And that piece of code is implemented as part of the class definition. And therefore, when you call this method, is actually going to access or process the data within the object correctly. Okay, so that is abstractively, that's what object really is. Okay, and of course, this is what we call a simple kind of object. And sometimes the object could be a little bit more complicated. For example, I could have an object actually contain another object. So for example, this object now have a new extra data. That is itself is an object. So this is what we call the basic type. Basic type you can think about is like integer, floating point, string. That's pretty much the basic type. Array is basic type, by the way. And then we have what we call the more complicated type or more abstract type, and such that this will include itself is an object. So essentially now you can see that I have an object which contain either simple type or more complicated type. And then I actually have the first level method for me to access this data, but this might also access this object. But when I access this pink object, I'm actually going through the method that was provided by that method. So that's actually what's happened. So think about object-oriented. You probably learn everything you need to learn about what is an object. An object is data and some of the method. And this thing put together, why we call it data abstraction? Because we want to put a bunch of data and the method together, and we basically want to represent an abstract concept. So that's called data abstraction. We not only say this data is an integer, but because we put these things together, and because we actually provide the interface to access to that, we actually have a very strong sense about what this data object and code put together representing which concept that related to our need to solve that particular problem. Okay, so this is the first picture about object-oriented, the way I presented. I just want to ask you any question about what I just said. So far, so good? Good. I like that feedback. Okay, so of course, now we're going to start looking at, this is, I think this one, I picked it up from the textbook. You can actually start seeing the really syntactically, how do I represent that? But I'm not going to use this example. I'm going to use my own example. Now I'm going to switch to my terminal. Let me make it a little bit bigger. So I'm actually going to first talk about a class. Oh, sorry. Do this. I want to give you an example of a class called class person. This is called class person, and basically define, I actually have a file for person.h, which represents the declaration of the class. But I'm actually going to directly jump into the person. How do I represent the person? So there are a few keywords which you will learn in the later chapter, which if you don't understand, you can either ask me, I will tell you, we will cover that a bit later. Let's actually look at the data part about this object. So this object is a person. And you can see that by the keyword. The first keyword is called class. I define this as a class. And then the person is the name of the class. And now you see there is a colon public core. This part, right now, you neglect that. That is actually inheritance. Because I actually hide information generically for every single object in the core. I will explain to you later, but I use inheritance here. You don't need to worry about that. Let's actually focus on person itself. So in the person, I have something called some kind of virtual ID. In the person, I have a name. In the person, I have some kind of hometown where they are coming from. But this is interesting. I actually have a information about GPS location because I think I want to know where the person is, where he lives. I want to know precisely what's the GPS location. So now I actually have a GPS location to represent that person. And there is a few other information. For example, you can see that that's pretty much all I define as a person. I look at their identity, their name, and where they are. That's pretty much I care at this moment. But later, when we learn the concept of inheritance, we can actually extend this person to a teacher. Then I'm going to include some other attribute, which is saying that, for example, what kind of courses he's taking, he's teaching that quarter. So let's look at the example about how I represent the attribute. So you can see that there is a class, a person, and then there is a two keyword at this moment. It's called private and the public. So private means that only the MESA can actually, remember I show you this picture? Let me see, where's the PowerPoint here? When I show this picture, I have a few data items inside. And if it's a private, if I have a piece of code here, this piece of code will not be able to access the data within this object if they are private. However, if it's a public, then essentially anybody from outside can directly access. For example, all the MESA over here, if they're public MESA, they should be public to allow other people to call. And this MESA, because they are part of that, they are by default be able to access to that. So which means that we try to protect your data such that only those who actually have the right call be able to access to that. Okay. All right. So this is the data. You have this attribute. For example, the first one is called person count, is an unsigned integer. The second one is a what we call virtual ID, which is a string. And then we have a name, I call it avatar name, and it also is a string, the data type. So essentially, just like you declare identifier in C or C++ or Java, is the type, and then the name of the identifier. And then we have this one is your address, which is a GPSDD, but GPSDD is actually another class. So that's why you have an object containing another object, and the type is GPSDD, and then the identifier is home. Okay, that's the private session. I keep those things there. All right, and then I have a few things called constructor. Constructor is something which when I create an object from the class, I create an object, I need to provide a bunch of parameters in order to create exactly like the object I want. For example, I want to create an object called Felix Wu. And I need to provide Felix Wu's, for example, my address or my virtual ID or my name to actually input. So those are the constructor. They are public to allow me to create all kind of object I want. And I might change my address when I move from North Carolina to California 22 years ago. I might need to set my home address differently. So I create a method in order to fit the need that I need to change that. Okay. And then I have a bunch of other method over here. And then you actually watch out. See, I actually put a virtual. This is what we're going to talk about when we talk about polymorphism in chapter 12, which is virtual represent is a virtual function. It's a way to represent another concept called polymorphism. But this actually gives you some idea. But this is actually way too complicated because you actually only see this and a person is actually very complicated. So I'm actually going to show you a much more simpler example, which is the GPS. We only look at the GPS, global positioning system location. That's why this is a file I actually included in the GitHub link. Okay, where's my GPS? Let's look at, I forget about this. Okay, this one, now this one is about GPS. Let's actually go over this line by line. You can see that over here, it's still the same thing. The keyword is class. And the class name is GPS_DD. It's a specific representation of your global position using two floating points to represent. Okay, so the class is called GPS_DD. And then you actually define using two curly brackets representing anything between that pair of curly bracket is actually represent your class definition. And then this class definition has two attributes, two data. One is called latitude, one is called longitude. Okay, I have a two number represent latitude and longitude. That's enough for me to actually pinpoint about where you are. Okay, and then again, I have something called constructor. GPS_DD constructor means when I construct a object, what kind of parameter I want to, I will show you the example, and you can see that I declare two constructor, one constructor without any argument, and the second constructor take two double, which means that you can use that to set the initial latitude and longitude. Okay. All right, so that's the data. And then I have two extra function. One is called get latitude, means that I want to actually allow people to say, what is my latitude, what is my longitude, and then I can actually have that. But the most interesting function over here is called distance. Distance means that it takes one argument, this is a function, one argument called GPS_DD star. It basically is a reference to another GPS data. And then you're going to calculate, the function is going to calculate the distance between this location and that location. So that we're going to see the detail about this one later. Okay, and don't worry about this. This I said not right now. This is a two generic function called dumpj and jdump, which is how do you actually connect the world from C++ to JSON, but we don't need to worry about that right now.
Professor?
Yeah.
So we use if not defined to avoid any replica of the classes when we compile, right? If not defined.
Yes. Yeah.
Okay, but you use it inside the class. I've never seen code where if defined used inside the class. Can you just explain it real quick? within the class and define that right now.
Define, not right now.
Outside the class.
You're talking about this one, right?
Yeah, what the
Okay.
outline is at.
Okay, so this is really for C programmer or C++. If you're Java programmer or Python programmer, you never need to do this, right? Never need to do this, this what we call preprocessor. So good question. Let me explain to you a little bit. So I assume some of you who know C actually realize why I do this. This is actually a C programmer or C++ programmer convention to make sure that this include file only got include once, will not get twice, right? But in general, if I say if define not right now, that means that if my compiler doesn't provide the debugging flag, not right now, then the preprocessor will just neglect between if define until the next end if. So this part of the code will be actually neglected. It's just for me to be able to having multiple versions of the same program and using the compiler time flag to actually kill. For example, let me actually show you a makefile. By the way, homework assignment number 1, part of that, you need to do makefile. So let me actually show you the makefile looks like. Okay, for example, if you look at the makefile, this line, when I have a C flag, I said, this is a compiler flag. Okay, just tell you what happened. The compiler is G++ minus std C++ 14. That means that I'm using particular version of the compiler, which is developed in 2014. Okay, so this is complicated about C programmer because we have new feature, we have a different version of compiler. Okay, so usually we hide all this inside the makefile, so you don't need to worry about this. But the important thing is that one of the flag I said minus capital D. This is actually in the C or C++ compiler that you can do this. You can see that I said minus capital D underscore ECS, whatever homework 7, right? So let me actually show you what I can do here. If I say this, if I actually say minus D, not right now. If I say this here, minus capital D, not right now, when I push that C flag into my compiler line is actually down here. You see my compiler line is always CC and then minus C flag. I always actually do that. And therefore, because that not right now underscore was actually defined in my compiler line, then those few lines will be included. It's a very useful, handy tool for me to remove, for example, debugging information. I did a lot of debugging, but then when I turn in, I don't want to remove all the statement, but I want to actually keep those later. For example, I want to debug and I use it again. How do I actually be able to on and off very quickly? I use this kind of debugging flag. Okay, minus capital D. Hopefully that gives you some idea. I mean, if you have any question regarding this detail about C++ compiler, please feel free to ask me and the TA. I mean, this is something which is a bit tedious, but very practical. My experience is that you don't have to know all this, but as you become more and more experienced programmer, you'll almost be forced to learn all this tool because you found out that you need to use this feature for that. So in other words, I'm not saying that if you don't feel you need to learn this, don't learn it, to be honest with you. But when you actually realize you have to keep adding, deleting, you realize there's gotta be some tool to actually help me do this better. In that case, you actually try to learn this trick to actually do that. In fact, I mean, in computer technology, there are just so many tricks and the people are just keep developing. So the thing is that it's kind of moving target. Therefore, for us, we need to just continuously sense about our need and try to realize that there must be something already there for you to either go to Stack Overflow or ask your instructor, your friend, try to see what's going on. Okay. Okay, so I'm actually going back to GPS, this file. Okay, any question before I show you the other file? Because this file is not complete. This file is just declaration. It doesn't show you the code. Yes, please. This star? Yeah. Okay. This star is it's actually something called pointer. It's a pointer declaration. I declare that as a pointer to a GPSDB. In fact, probably a better way to do is actually do this. Wait a minute. Oh, okay. Another way to do this is do this. M sign, that means it's a reference. So reference is a standard C++ way. Star is kind of legacy way to represent something from C. I will try to not use the star as much because I don't think it's really needed for most of the applications. Okay, but it's good for you to know because there's a lot of people who are still using legacy code. Okay, thank you. Let me actually try to get back to this part. Okay, any other question? All right, I'm going to show you this piece of code now. Okay, this code is called GPS CPP. You can think about this is really to talk about the implementation of the class, the size, the specification about what is the type of the attribute. So let's actually look at this piece of code. Let me actually just go over here. It's not really long, but let's actually look at this first because this is for GPS.h. So GPS.h, what I already showed you is a class. And I actually include that file to say, okay, this file actually use that declaration. And then you can see what I did is a constructor. So constructor is GPSDD, but now here is a trick. When I actually really provide the implementation, I have to say the class name and then 2 colon and then the method name. Let me actually compare this to you. You see what I'm doing here. This is important. It's a small detail. When I declare this as a method, this is GPS.h on the top. And you can see that I have a constructor, which is a GPSDD. So the function name is GPSDD. So remember the color blue, okay? Color blue is a function name and color green is the class name. So when I actually declare in the GPS.cpp, which is the file, is really implement the class, you can see that I actually have to put the class name and then with 2 colon, and then with the method name, GPSDD. This will clearly tell the compiler what that function is for, okay? And inside here, you can see is very simple. I just basically say there are 2 attributes. I set this to be 0, the latitude and longitude, and this is a keyword called this. This represents that this is an object. So when I say this hyphen greater than to the latitude, that's again, it's a pointer representation, and basically say this particular object when you create it, because this is a constructor, I create an object, and after I create, I have the data space, I set the latitude to be 0, the longitude to be 0 as well. Okay, let's look at the other function, which is another constructor. Essentially, now I have 2 attributes. One is double argument latitude, double argument longitude. And what I did is I just set the latitude to latitude, longitude to longitude. Okay, that's just the initial configuration about the data. So after that, I actually will have a data. Any question? Okay, now I'm actually going to get to the most interesting part, which is, okay, here you see I have the get latitude, get longitude. That's just basically return the value when you actually need it. Again, it's the method is usually the class name, which is the green, 2-column, and then method name. All right. Now I want to go, don't worry about dumj. You can see here, I actually do if define, not right now. Okay. I'm actually going to skip this part of the code and directly come in here. So this is the function called distance. This is the function that's most important. It's called GPSDD is the class name. Distance is the function name. And then take the parameter called GPSDD star, which is a pointer to a GPSDD object. I call it another. And what I did is I actually first check whether the another is null. That's the typically C programmer, you have to check. Anytime you pass a pointer, number one, you actually try to see if that's actually a null. If it's a null, then you return 0. And then I'm going to call a function because to calculate the distance between two GPS location is outside the scope of this lecture. However, the code, you can actually see that on top of that. I actually skip it, but this part of code is you actually can download it from GitHub. It's essentially the implementation, the calculation about a function called geodata source distance. You can see that it actually takes a 5-parameter, latitude 1, longitude 1, latitude 2, longitude 2, and then the unit. Unit is basically whether it's a mile or is a kilometer. It's depending on whether you're M, you're K, or your whatever N is. I don't know what that is actually. I always use mile. But that is the detailed function you don't need to know. It's just some code I actually downloaded from the website. It's open source, and then I just call it geodata source distance. And I just use it, I test it, and it works really well. So you can see here, if the another is actually not null, then I just call geodata source, this latitude, this longitude, another get latitude, because that is a private, I cannot directly access from another. So I have to call another get latitude, another get longitude, and M, which is a mile. So I just call this function. This function is going to return me a double value. I'm going to return to whatever called distance. Okay, so that is the implementation of this distance. So now I have about 4 minutes. I'm going to show you how I'm going to test it. Okay. So let's actually look at the test program, which is you can actually play around. I really want you to play this program yourself. So this program is called test GPSDD. Is basically how do you test that? So again, I'm actually include the GPS.h. I include that definition. And this is my main program. I actually provide the Davis address, which is, I don't know if you know, this is actually the city of Davis. Our GPS under the DD formation is 2 numbers. One is 38.5, that's our latitude, and longitude is minus 121.7. That's what I have. So, okay, I actually write the program. You can actually enter another 2 longitude attitude. So basically using this is probably Java programmer and the C programmer should know this ARGC, ARGV, which basically are including ARGV1 as the latitude, ARGV2 as the longitude, and using this function called A2F. A2F is a function that's called ASCII to floating point. So I convert a string of number into a floating point, and then I enter this function. You can see I enter this function called GPS Davis dot distance of this current. So I essentially use this tool to create another object of Davis, so current, and I already give the Davis address inside here. So essentially, when I say the distance to Davis is GPS Davis dot distance, I call that function and then provide the current as a pointer to that about this. Okay, so essentially what I'm going to do, create an object for GPS, and then you have to find the distance. Okay, let me actually just very quickly, I have about 2 minutes. I want to show you how to run it, and you can run it yourself. Give me 1 second. Let me see. First, I have to compile. So G++ minus std minus st is equal to C++ 14. Okay, and I'm going to compile gps.cpp and test gps.c, and then minus O to, I say D to Davis, distance to Davis. So I compile this program, no error, come out. Okay, so I'm going to run the program. Anybody want to pick a location? I can actually calculate location, that location to the Davis distance. Can you pick a location? Anybody, any city?
Sunnyvale.
Sunnyvale is too close. Okay, fine.
Okay, fine. Antarctica or something.
No, Sunnyvale. Let's go to Sunnyvale. Okay, I was picking Paris because this is my daughter. She's in Paris right now. Don't worry. I'll go to Sunnyvale, California, right? So I go to Sunnyvale, California. Where's Sunnyvale, California? Show this here.
Yeah, I think it's near Mountain View.
Okay. Anyway, I'll go to Mountain View, and if you click this, let me show you this. You can see that when you click on that, you see two number, 37, and then can you remember that? 37.38 and minus 122. Okay, so I'm actually going to run this program. /d to Davis. What's this one? What's the first number?
38.365 or something.
That's fine. 37.1. It's okay. It's okay. It's around that area. And the other one's 122, right? Minus 122 or minus, okay. Okay. That whatever one, okay. Okay, it gotta be wrong. It says that from Davis to that location is only 25 miles. No. It cannot, it must be wrong. Let me actually pick it up because if I make a mistake, let me go back.
Roughly 100 miles.
3738 and 12208. Okay. 38 and 120.
37.38.
Okay. And then 12201, right? That's actually better, right? That's actually better. So you can see that I can write a very simple program using the information Google Maps providing. I can actually calculate the distance using object-oriented. Okay, you can play around and you will have some fun.
The distance function.
Give me 1 second. Let me